Welcome to Rudy's Electronics Lab. And in my series of episodes on the Rohde Schwarz CMW500 unit, I today want to look further into its hardware and its configuration, and also the self-test that the device can run. Because this is quite an amazing piece of hardware. It's built in a time basically to test like 4G mobile phones at the moment that the chipset of these mobile phones actually did not yet exist. So it's doing that same type of functionality mirrored in the base station side, which is basically it is simulating just with general purpose type of hardware, and sometimes, as we will see, also with custom built silicon hardware by Rohde and Schwarz itself. So I want to take a closer look at that, but I also want to be sharing the more detailed self-test. So if you ever want to repair such a device yourself or check its configuration, this might be kind of useful. So I'm leaving these at the end of this episode as a kind of appendix. And as you will see there, this is not only the configuration menus, but also a full self-test in hardware, including loop testing. And in contrast to the CMW, the predecessor of this device, you don't even have to connect cables for the loop testing. Actually, it's all built in via this combined connector. So automatically he kind of goes through the whole frequency range up to 6 gigahertz and kind of test like all the different attenuations with sending out signals, receiving them, if everything is still within spec. So it's very cool what it can do there. But let's first go and take a brief look at its hardware. And the way it's built is rather similar to a lot of Rohde and Schwarz devices that I've seen of this type of category. So it's like with all modules being plugged in. And as always, there is like a big heavy piece of metal that is protecting it all. Unfortunately, unlike the CMU, there's not like a great block diagram with information on all the different modules that could go there and how they're supposed to be wired together and all of it. Actually, the wiring is not terribly difficult anymore complex in this unit anymore, but this type of information we're not getting anymore, and as a matter of fact I was not able to locate the service manual anywhere for this device. If you have one, please let me know. I did share on IO groups already all the other documentation that I could find, but no service manuals really. Okay, so let's take a quick look at the device. I'm gonna turn it over a bit. There we go. It is connected to the mains earth, so we should be fine. Yeah, so we see all the different modules in this device. This is actually the single channel configuration, but pretty well equipped with all the different options for signaling, etc. So we got 4G, we got Bluetooth, we got CDMA 2000 and other things, etc. But you can have more slots in here, and that would create basically the double channel version. As I have already explained in my earlier video, the hardware of the device is always 6 gigahertz. So it's quite simple. So basically there's the RF cards, there's these red cables coming to the RF front end where some switching is going on. If you would have these additional channel here, there will be a couple of more cables. I think that's kind of it what goes on in terms of wiring inside the device, except maybe when you have the specific IQ digital I/O cards, then you might have a little bit more wiring going on. I'm not entirely sure about that yet. Other notable things is that my unit has like a SSD drive already built in. I guess that is not original. I checked out and I saw several like regular hard drives being sold which were apparently taken out of CMWs, but this device already upgraded to a SSD. That was the way when I bought it. If you got one and that has not been done yet, I would consider basically to copy the whole hard disk, like really making a mirror to an SSD, just to make sure that your hard disk doesn't die out on you. Yeah, so there's not so much to see here. I'm not going to take it completely apart, but I want to look at a couple of things with pictures that I found, so we see a little bit more about this actual configuration. We can take a look at the other side. Here we get what we could be, let me move it a bit. Here we are what we could be calling the, Rohde and Schwarz calls this the motherboard. It's not where the CPU resides, so we could also call it the backplane, basically. So this is basically where all the cards go into. All the slots are basically on the other side of this part. Actually 2 units here, subunits. But it's a little bit more than a passive backplane here. There are a couple of FPGAs actually on this board itself already. on the other side. Later we're going to take a look at them. And I think that is kind of the computing hardware that will be required for the device in configuration where there will be no additional signaling cards in there, and they still needed a bit of that. And apparently they didn't put it on the CPU board, which seems to be their own design after all. But the FPGAs are basically on that board here. Another notable thing, actually a bit of a surprise, because a lot of stuff that you find in here is stuff that you would expect to find an enormous amount of computing hardware. But there's a little thing that I'm still puzzled about. Let's go right over here. Yeah, let's see my screen. Yeah, right over here. Can you see what it is? Crazy enough, it's a SIM card slot. And I don't know what is doing there. Was the idea that there would also be a device of a version of this device that would be a mobile station simulator, so you could test base stations like the CMW500 and the CMW500. I've never seen any talking of any of such device, but if it was, then maybe this was already foreseen as hardware to do that, or maybe some kind of self-testing where it can go through testing with a mobile phone configuration. I really don't know, but it's a BTS simulator, a base station simulator, so I really don't get why a SIM card, which is part of the mobile station, the MS, should be part of this device at all. A little bit puzzled about it, but no, that's the way it is. Yeah, I just mentioned a crazy amount of computing hardware in here, and why is that really the case? Maybe that requires a bit of background here. These devices are made basically to test 4G mobile phones before the chipsets of 4G mobile phones and base stations were actually there. So it's really trying to do that same functionality either in generic computing hardware, but not just a little bit, really like dozens of FPGAs and DSPs and PowerPCs and other devices in here, but also several pieces of custom silicon of Rohde and Schwarz that do that functionality. So it was really to build something that later all would basically be integrated into a chipset in a 4G mobile phone. But that didn't exist yet, so they really had to build it with an enormous amount of computing hardware. And I just told you that I'm not going to take my complete unit apart. Well, I'm going to do that a little bit because I'm going to look at you together at one of the cards that goes into the device. This is the broadband analyzer card plus the broadband ARB generator, which is on the daughter board in this card. And I got this spare unit because I needed actually to get something repaired about my device. So I thought we could take a close look at that. It's all encapsulated in metal. Since this is most like processing power, this doesn't require extensive RF shielding for signals coming in, but it's more to prevent signals coming out of the device. And so here we got that card, and it is pretty amazing the amount of compute power on here. So we see a number of Rohde and Schwarz custom silicon parts. We see another 3 or 4 FPGAs, I think. Later on I'll show you an overview of it. Still got to make that. We got some DSPs here, and I think there's even a power PC processor as well. The project of IBM and Motorola together with Apple. And we got a daughter board on here, and that daughter board actually contains the ARB generator and its memory. There's more custom silicon on there as well, and memory. It's got a quite delicate connector and a lot of warnings around it, so I'm not going to take it off right now, but later we'll take a closer look on the inside. We'll take a closer look on the inside to see a little bit, you know, what was really the state of the art at the time that this device was being designed. Now let's start our exploration still with the outside device, with the connection. This is my own device, and it does not have that many outside connectors. We got the LAN remote on the top, quite important if you have to upload waveform or control it remotely. On the right side we got a trigger in and out. We got the generic USB A and USB B connection. We got a GPIB bus on the bottom. And we got reference input and output for the 10 MHz signal. Depending on the unit that you bought, you could have more hardware there. I'm showing some additional hardware parts here on this picture that I got from a unit on the internet. This one has a LAN switch, and that LAN switch gives access to the internal IP network of the CMW, so the internal IP subnet. There are six connections on the inside and 2 ports on the outside. This one also has the digital IQ option, so it has like the IQ signals in a digital format in a small condensed connector. Actually, it's the same connector as I got on my AMU 200 fading simulator of Rohde Schwarz, so you'll be able to connect this one together. And that one also provides 2 additional AUX auxiliary buses in and out, basically to do mostly for syncing related to the IQ signal. And this one also has a DVI connection, and I regret a little bit that my unit does not have a DVI. Maybe I can find it as an option, because I would be interested to see if I can get like a larger screen resolution of several of its functionalities. I've been looking around a little bit in the documentation of the device, and apparently it does support like a large resolution 1920 by 1080 if you do it in external screen mode only, and if you have the cloning mode, it's the same as the internal display 800 by 600. But I'm not exactly sure how actually the screens of the measurement functions would come out if you have that larger resolution. Perhaps one day I can get my hands on it. Still more hardware in another unit. This one is particular because it has an additional Ethernet port, but that's not a regular one. That's for data application unit, the traffic that it generates. And this is basically the actual data that is being transmitted or being exchanged by the instrument for type of testing, whether the data actually arrives, for bear testing and all that type of stuff. So it separately goes directly to the unit that generates and receives that data is being transmitted. Also additional on this unit you find a number of additional sync ports that were not on the previous devices that we saw. The device is also available basically with an additional digital IQ board that gives you channel 5 to 8, and again that with a number of additional auxiliary connections. Now in the unit shown over here we have the LAN switch and the data application unit Ethernet connection we already saw before, apparently as one unit that is also available on the market. But there's also something new, a PCI Express input port, and apparently this is being used when you got multiple CMWs and they're doing very advanced type of scenarios, which could include all of these CMWs basically representing, simulating different base station or some complicated versions of carrier aggregation, I suppose. And then for 2-channel version there is also the option that each of these 2 channels basically has its own GPIP bus fitted on the back of the device as an option. And we're not even done yet. I couldn't find pictures of the back of the device with this already installed, but you also have a CMW control unit out, and then you can connect it to the switch unit as you see here on the picture. You also have the possibility of digital audio I/O, so that is the version with the special audio board in it that I talked about in the earlier episode, with that analog connection on the front side and the Philips Sony SP diff interface on the back side. And there's another interface, I couldn't find a picture of it, but that's another multi-CMW control interface for complex scenarios. And I think that concludes kind of all the different I/O options or connections I've seen on the back. This is my Frankenstein picture where I kind of all put them together. So this is an almost fully loaded unit. Not everything yet, like the digital audio, etc. But this is what such a version could be looking like, more or less. Talking of external devices, some of you might have noticed some pictures before in the presentation where you saw additional devices standing on top of CMWs, and in most of the pictures actually is the CMW control unit, which actually I think is just a Windows computer which has a GPIP bus built into it and which is completely designed by Rohde Schwarz, also the motherboard apparently, and designed to have excellent EMI values if you use it in the lab, and also seems to be in an older version of this particular computer that you could match if you wish with your CMW. Now further exploring the unit on the inside, here you see the bottom side of the backplane. We already looked at before when we saw the SIM card slot, but some details are pretty amazing. I'm going to highlight here, for example, how you see like this huge thick wiring is coming up from the power supply unit going to the backbone board, but then just next to it all these very small chips with small pins. Looks amazing in a sense, super robust. I took a number of pictures also of this backplane and of other stuff in the device, and I've been playing around with pixel shift on my camera, a Nikon Z8, and then I got 180 megapixel photos, which actually were able to relieve small details and chip types, etc. much better than the regular type of resolution of that camera, which is not too bad at something like 47 megapixel either. And then here we see the top side also in higher resolution, and we see the backbone board from the top side, and we already see there's actually some chips there, not only kind of only bare connectors to connect the boards to. But at this point I'm not going to take this all apart. I'm going to go to a picture that I found on the internet so we can further see what we find there. And here is that picture. You see a couple of big pieces of silicon. So the really big ones with the white area in between, these are actually PCI Express switches, because all the boards I believe are PCI Express interfaces, even though they don't use the type of slot that a regular computer would use. But we also got a couple of FPGAs on this board, which I believe are FPGAs that are going to be needed in any configuration, also when you do not add specific signaling cards to the unit. So Rohde Schwarz apparently decided to put them then on the backplane board. The backplane board is actually made of two boards if you look well, and also that other board got some active electronics and even some FPGAs fitted to it. And looking up some of the chips we also see on that little board that I just showed you, I noticed that one of them was a asynchronous digital crosspoint switch by Analog Devices. I looked them up, even on mouse, they're 300 euros a piece, even today. In my video on the CMW configuration, I already mentioned that there are units with different CPU boards in there. And these are two pictures of CPU boards I found on the internet. I think the left board is a bit older than the right-hand board. We see kind of most of the common components, even though it's a different shape than in most computers. I do note that the one on the right has a SATA connect, or a SATA connector fairly close to the two Ethernet connections to the right. I don't seem to see that one on the board on the left, unless it's perhaps some of these connectors all the way to the top right and top mid. I'm not 100% sure, but anyway, the different CPU boards with different specs here. And finally, the original device, at least some of them were apparently shipped with the regular type of hard drives. My device has a SSD. I think it's an afterfit, although even later versions Rohde & Schwarz might have put in SSDs in the units as well. And that's going to be it for now when it comes to the internals. There are many more boards inside, but I couldn't find much more information on pictures with these boards actually exposed. And again, I don't want to kind of damage the units I got right now. And that brings me to the end of this episode. I hope you found it interesting to take a little look into the workings of this device. As already said, as a kind of an appendix at the end of this video, I'm going to leave like the whole boot up procedure, a walk through all the configuration settings where it recognizes like all the hardware and the software licenses, as well as the entire self-testing, which is actually like dozens and dozens of pages of specific information about testing all the internals of the device. And I hope this information might be useful for people that are actually working on repairing a device or trying out configurations, or just finding out even how a particular configuration and hardware or software is presented back on the device, because it's sometimes different than the way it is presented, both in name as in coding, as you find it in the documentation of the CMW. Now, hope to see you again on one of the other episodes where I'm going to take a look more at the CMW, but then actually using it for all types of different purposes. See you soon.